variety of jobs for CREST, and we work throughout the tidal reaches of the Columbia River, which goes up to Bonneville Dam on both the Oregon and Washington sides. We also, in addition to monitoring our restoration projects, we contract with other agencies and organizations to assist them with their data collection, and that ranges from fish community sampling to vegetation surveys, collecting macroinvertebrate samples, also helping them with data entry, QA, QC, sometimes reporting. That's about it. Sometimes we'll process macroinvertebrate samples. We have a small lab in our shop. One of the unique things about our location, working both in Washington and Oregon, is that we have different project funders. We also work with different agencies for our permits and monitoring protocols. It's an important distinction because in Washington, we have Department of Ecology, or DOE, and they handle all the wetland permits, which our projects have to go through to go to construction. On Oregon, we have the Department of State Lands, so they do similar things, but in remarkably different ways. And then different WDFW as opposed to Oregon Fish and Wildlife. So there's some important distinctions between working in the two states, even though in Astoria, we are really right on the border. It's very different working on each side.
So April mentioned that we work with other organizations to do monitoring or data collection for them. Here's a list of the latest groups that have contracted us to do their monitoring. First up, we have, we were up in Willapa Bay, which is on the Washington side. And there we did fish community monitoring and prey utilization by trap netting 2 reference sites as well as 2 restoration sites. And that was in the spring months. We did that for 3 years. With that study, they wanted us to do non-lethal gastric lavage of salmon. We did that to sample prey selectivity. We compiled the data and submitted analytical reports after each season. For the National Park Service at Lewis and Clark National Historical Park, we did some monitoring at Colwar Creek and Otter Point. It's 2 restoration sites on their property. And there we set out fallout traps to sample prey utilization. And we processed those samples in our lab. And then data from the restoration sites was compared with reference sites, which was at Alder Creek, also on their property. With the Pacific Northwest National Laboratory, we assisted in fyke net fishing at a variety of sites in the lower Columbia, set out fallout traps, collected benthic grabs, and sampled drift with Newston nets. And that was all part of AIMER 1, which I'll get into shortly. With LSEP, Lower Columbia Estuary Partnership, we've been working with them for a number of years, conducting vegetation surveys at reference and restoration sites. And we also help them collect biomass data for their ecosystem monitoring program study.
Okay, so you got a real quick description of kind of what we do. So why do we do it? Why do we monitor? Why is it important to monitor? The answer seems really obvious. How do we know restoration actions are successful if we don't go back and check? All of our restoration projects are based on hypothesized results. These are all supported by existing data, but at the same time, every project site is a little bit different and has varying site-specific characteristics. We know that there will be project impacts, but we can't always be sure that the impacts are what we predicted or result in an ecological lift at the site. Also, projects may have ecological benefits, but end up impacting private property if not correctly engineered. So not only do we need to be aware of environmental factors, but also the social impacts and potential negative impacts the project may have. A great number of our projects have similar restoration elements. They're culvert replacements, levee breaches, really have an underlying theme of reconnecting lost habitat, historical habitat, and improving the quality of those habitats. Let's see. Every once in a while, we'll get a more unique project type. We're working on West Sand Island, which is different from most of our projects, access-wise, and just the habitats on this island are pretty unique. For those, we do more intensive monitoring. There's also a project on Savi Island, slightly upriver in the Columbia River, where we're looking to restore wetland prairie. So for projects that have more unique plant communities or specific kinds of habitats, we monitor those more intensively. Let's see, so did we meet our project objectives? That's the first question we want to answer. And since we do so many of these projects and plan to continue, what can we learn from past projects to make our future ones better? Measuring how our sites respond to various restoration actions can help inform our future projects. At one site in Washington, we had a very unsuccessful time replanting the adjacent upland because heavy equipment, large excavators had compacted the soil to the point where we could really barely dig in it. So what we got was a plant community that was pretty much all non-natives. It was right by the road. It really wasn't conducive to native species that aren't as competitive surviving there. So now in future sites, we make sure that if there's some compaction, that the ground is mechanically roughed up so that we can replant. Because one of our goals at all these sites is to make sure we have a good diversity of native vegetation. And are our projects cost effective? Funding is really competitive, so we need to make sure that we're getting the bang for our buck. Some of our projects come in at over $1 million. We'll talk about a couple of these. They're some of the ones we monitor the most intensively. And when we're spending that kind of money, we need to see measurable improvement in the site conditions. There's always things to improve upon and build upon. Without monitoring, we would miss a lot of these little lessons. The more we can demonstrate that restoration actions improve salmon habitat and benefit salmon survival, the better we can justify funding for future projects. Because funding is very competitive, as Narayan will discuss later. There's always exceptions, but in general, all restoration work is good work, but it's not all going to get funded. So we need to make sure that our projects are well thought out and are really the most beneficial to salmon survival. Okay, cost benefit. So how do we measure success? The first step is to look at project goals and ask, what are we trying to do? Are we looking to restore and improve passage, increase channel or habitat complexity, and improve water quality conditions? Once we've identified the specific project objectives, then we can start discussing what metrics would best demonstrate site performance and what information would help us better select and design projects in the future. One thing we try to keep in mind is not only having a data set for individual projects, but also collecting data in a way that informs restoration on a landscape scale level. Salmon have such a dynamic life cycle, and with the degree of habitat loss they faced in the Columbia River, we may not fully understand their migration behaviors because they lack the habitat accessibility or diversity to fully express their life history strategies. So we never want to just assume that we know what's best. With this in mind, we look for metrics that measure site-specific performance, but also tie together data from throughout the river and estuary. Even if we're not the ones who are conducting large-scale research, it's important that our data support larger research efforts. So, one of the previous slides, you see that we work with the Lower Columbia Estuary Partnership and Pacific Northwest National Laboratories. Our data can be shared with NOAA. So we're not just learning about our specific projects, but we're also building this larger data set that will help inform us and partnering organizations in salmon habitat restoration.
Hey, April, a couple of questions.
Okay.
Is one of those entities serving as a repository for data that's collected throughout the estuary?
Sort of. That's something that, agencies have been talking about since you were here.
Right.
And even before. So the Army Corps and PNNL, and CREST has helped with this a little bit to kind of beta test it. There's a database they're working on called Encore. Are you going to talk about that later? And it's supposed to be a repository for all of the BPA funded projects. We're all supposed to collect the same data using the same protocols and metrics.
Yeah.
And then we QA QC it and submit that to LSEP. The Encore isn't actually up and running. So we're submitting data and LSEP is storing it. But it's still a work in progress.
Okay, thank you. And my second question is related to how you fund your monitoring efforts. Clearly you get periodically contracted for a specific job, but for the projects where you need that more intensive monitoring, where there's something new to be learned potentially, are you building your costs into the overall project budget that you request from BPA and from other funders?
Yes, so to do additional monitoring above the standard metrics that BPA wants all their project sponsors to do, we apply to them for increased monitoring and also for increased or more expensive monitoring equipment such as the pit tag arrays. So we get that approved through BPA. For some of the sites in Washington where we get additional funding from the Salmon Recovery Funding Board, we can apply to them for monitoring money. Usually any grant funds have to have some kind of restoration action attached to them to get monitoring money.
Okay, that helps. Thank you.
Yeah.
Good job. All right, I'm going to talk about fish-based monitoring metrics. So this is getting down and dirty. This is what we have in our toolbox. These are all the metrics that we have to choose from. Aside from spawning surveys, our metrics focus on juvenile salmon monitoring and research. Fish sampling provides a direct indication of project success and habitat use, but it's reserved for a select few sites. Because of funding, like we've been talking about. Permits to handle ESA protected species, which salmon are, aren't just handed out like fortune cookies or anything. And the work is very intensive. So we have to either apply for permits, we have to apply for permits and also have to choose whether or not it's feasible to fish certain sites. At a couple, so can you see my mouse pointer?
Yeah.
Okay, so down here we have an example of our fishing setup. These are the wing nets, this is a sock net, and this is a live box. And keep in mind, this is for juvenile salmon, so periodically we just sample our box and see what we get. That's here and over here too. At a couple of our sites, we have installed pit tag antennas. Pit tag antenna arrays evaluate the residency, timing, returns, and the use of habitat by tagged fish migrating through the estuary. And that can be seen here. It's kind of hard to see, but in this gravel bed here is embedded 2 antennas that are constantly sending out a signal and searching for pit tags. This is at Megler Creek, right across the river from Astoria. Snorkel and spawning surveys are less invasive, that don't require permits and are used to monitor presence, absence of salmon. And they're good for a comparison of species using the site before and after restoration. Down here, we have a picture of me snorkeling at Megler, and these are little coho. They're littered in these little pools here. So with all these metrics, how do we start whittling down and seeing what's feasible and affordable? What can we do?
The most common question we get consistently is about salmon presence absence. People want to know if we're seeing more salmon, what species we're seeing, how frequently, when. And they're all really good questions. It'd be great to have our fish data for every restoration site. But as Narayan stated, handling salmon at every site just isn't feasible. And unless we're looking to answer a broader question, presence absence data isn't always the most valuable information to have. We really just don't need fish data from every site. Part of the reason for this is that over the last 5 years, CREST has completed over 20 restoration projects. So that would be a lot of fishing. And when working with ESA listed species, it's important to balance the impacts to the species with the monitoring and research needs. I believe the statistic is every time you handle a juvenile salmon, you decrease its survival chance by, it's anywhere from like 5 to 15%. So NOAA is not very excited to hand out handling permits for every restoration site unless you have a really specific research goal. Another important thing that we try to keep in mind is that we're not the only agency collecting data on salmon habitat restoration sites. NOAA, PNNL, LSEP, there are a lot of different organizations that are collecting data. So one of the things we ask is, how can we complement that data, that larger data set? How can we build a larger data set without directly handling fish? And that's when we get into habitat-based monitoring metrics. These revolve around vegetation, site elevation, and of course water quality conditions, which, temperature and dissolved oxygen are proven limiting factors for juvenile salmon. Restoring native marsh plants is an element in nearly every project, and this ties directly into site elevation. The site elevation determines whether we're going to have a bare mudflat or low and high marsh, and these represent really different plant communities that support different types of macroinvertebrates, amphibians. So elevation tells us how frequent and at what duration the site is flooded. We can also look at the types of macroinvertebrates that the site is producing and measure changes between, say, a non-native monoculture of reed canary grass and a diverse native marsh plant assemblage. And we found that they're actually very different in terms of production. Some of the metrics listed on this slide can answer more than one question. So when we're looking at elevation measurements from tidal channels and across the wetland surface, we can use these to calculate habitat opportunity. So that tells us the water level and if there's adequate water for salmon to get in and out of the site. It also determines what kind of plant community we're going to get. And we use existing data for a lot of this as a solid database on what elevations native plants thrive at throughout the different tidal reaches of the estuary. And as we go upriver, the tidal influence changes, salinity changes, So we see different plant communities, even native ones, at different elevations. So we've got to keep in mind where we're at when we're looking at this as well. Personally,
April, maybe you can describe the change in tidal range as you move from, say, Astoria up towards Savi Island.
Yeah, so it's still hard for me to wrap my head around. In the lower river, the river is dominated by tidal influences. So we have tidal swings of up to 10 feet. And our work is really scheduled around that. It's more saline up to a certain point. As you move upriver towards Portland and Savi Island, it's more of a fluvial dominated system where you have, maybe 3 to 4 foot tidal swings, raises and lower in water elevation with the tides. But it's really dominated by the freshet, which is controlled by Bonneville. So in the lower river, we really schedule our work around tides. That's the dominant factor. Upriver, we get this crazy flooding in the summer that makes a lot of the sites inaccessible. Savi Island itself will go from being like an open forest to us being able to boat through the trees. It floods so dramatically.
Thank you, that helps.
Okay. Yeah, so personally, I think these habitat-based metrics can be more informative to our projects because they're what we focus on when we're actually doing the projects. Our objectives are site elevation, water quality, and site productivity. So now we get to talk about the really fun stuff, which, that's, okay, so now you've seen a list of metrics that we've used. Now, how do we select these? Narayan kind of touched on the limitations with funding. We've kind of talked about all the things we want to know. And these tidal wetland ecosystems, they're so complex that there's really no limit to what we could study or learn. We can look at soil chemistry, the vegetation, and their successional changes, how inundation impacts plant community assemblages, the fish use, water chemistry. We've helped some organizations look at carbon sequestration. And I mean, the list just goes on and on. So, personal interest and curiosity about these natural systems can easily become a distraction from what we really need to know and what really needs to be studied. Based on project goals, some of the questions we need to answer are, does water temperature or DO pose limiting factors to habitat use? Does the channel morphology impact habitat opportunity? In our project design, are we increasing risk of stranding? So when we design projects that are diked or have culverts and are restricted to salmon, we'll go in, either remove the obstruction entirely or replace it with a passable culvert, and oftentimes we'll excavate new channels or starter channels. And one potential impact of these as the tide goes out is that salmon are going to get stranded in the wetland and small pools that'll overheat. So we need to make sure that we're not increasing risks of stranding. We also have to be realistic about the limitations to implementing a monitoring plan. Okay, here we go. Here's an example of a table I use when we're drafting our monitoring strategies, and we do this for every site. We look at what the restoration actions are, so what's going to happen on the ground, what the project goals are, the objectives, and then we select indicators that are going to inform those objectives. And to start with, we just include everything that would be informative, and then from here, depending on funding, site access, we kind of narrow it down. there are some sites that are really hard to get to. They're farther away. So that's a constraint in monitoring. How much time do we have to focus on each site? And this helps us kind of prioritize which sites we're going to monitor too.
Okay, so limitations in monitoring, funding, that's a huge one. I'm going to talk about funding because it's probably relevant to all of you as your scientific careers develop. Bonneville Power Administration is our main source of funding. They formulated the CERP, Columbia Estuary Ecosystem Restoration Program, along with the Army Corps of Engineers. And CERP is basically, it was put in place to restore lower Columbia River estuary ecosystem, and it was mandated by the 2000 Federal Columbia River Power System Biological Opinion. As a result, BPA provides funding for juvenile salmon habitat restoration as well as monitoring in the lower Columbia River as mitigation for the dams on the main stem. The objectives of CERP are to increase the capacity and quality of estuarine and tidal ecosystems, to increase the opportunity for shallow water habitat, and to improve ecosystem functions. Action Effectiveness Monitoring and Research, or AIMR, was the effectiveness monitoring strategy that was put into place for juvenile salmon habitat restoration projects in the lower Columbia River. And the purpose was basically to determine if these restoration projects are successfully creating juvenile salmon habitat. And the organizations that sort of structured the framework were BPA and LSEP. The hypothesis of AIMR basically are fish responding well to restoration, and is the habitat responding well to restoration. AIMR efforts are designed to answer these questions by collecting actual fish data and collecting habitat data as well in a 3-level system, which I'll get into. This approach is seen as holistic because both fish and their habitat are sampled and they're separated in response to feasibility. Collecting fish data is intensive, as we've talked about, and expensive, whereas habitat data collection is less intensive, therefore more feasible. A baseline is important in order to answer these questions, therefore pre-restoration monitoring is required. So there's a graphic of the 3 levels, the structure of the 3 levels of AIMR monitoring. So level 1 is a fish-based habitat monitoring approach. It is the most intensive, the most expensive. This is the data that we're after. We do this by trap net fishing, benthic grabs, and drift collection with Newston net. It's done by PNNL, and it's done annually since 2016. Level 2 is a habitat-based approach to monitoring, and this data is collected with vegetation surveys, fallout traps, and channel cross sections. And this work's done by the Lower Columbia Estuary Partnership, and it's done 1 year pre-restoration, 1 year post, 3 years post, and 5 years post. Level 1 and level 2 are done at a subset of sites, of restoration sites, and each restoration site is paired with a reference site. And these 2 groups have contracted with CREST, and we've helped them collect this data for these projects. Level 3 data is the least intensive, therefore the most feasible, and all projects are required to do level 3 monitoring at their sites. The data we're after is photo points, water surface elevation, water temperature, and sediment accretion. And all practitioners using BPA funds to conduct juvenile salmon habitat restoration are required to do level 3 monitoring. And that's done at, so this timeline is done at every site, 1 year pre-restoration, 1 year post, and 5 years post. Each project may have slightly different goals, but data shouldn't be site limited. Salmon aren't stationary, so our data shouldn't be either. Therefore, to make all data collected at Lower Columbia River restoration sites comparable, a standardized set of protocols were adopted. These protocols allowed data to be consistent internally and with other organizations. NOAA, PNNL, and CREST work together to develop these protocols, and they're used to monitor in the Lower Columbia. These protocols have also helped guide our internal monitoring as well.
Okay, so now for some more fun slides. We're going to show you some of our projects and talk about the monitoring that we've done at these. We've recently completed Megler Creek. You can see that on the right. So this is Astoria. This is where we're at right now. Megler Bridge over to Washington. Port Columbia was completed in 2010, I believe, and Megler we completed just earlier this year. So while we generally focus on habitat characteristics, occasionally we do get a sample fish community. These sites we selected partly because they were the most expensive and partly because of the circumstances around them. They have similar landscape positions. There's some of the few sites we do that connect directly to the river. A lot of times we're on Sauvie Island, which is in the main stem, but there's a lot of internal channels. We'll work in Youngs River, Lewis and Clark, tributaries to the Columbia. So these are kind of unique in that they open up habitat directly to the estuary. The northern channel in the Lower Columbia is characterized by really steep cliffs and the development of State Route 4 and also Highway 101. These conditions, both natural and anthropogenic, they've resulted in almost zero off-channel habitat for migrating salmon in the northern part of the river. Since the estuary acts as a funnel for all Columbia River Basin salmon, our fish sampling focuses on these lower river restoration projects. And we're narrowing it down more to these two projects because of their location and this lack of off-channel habitat along the stretch of the river. These off-channel habitats provide really critical refuge and foraging for juvenile salmon. Juvenile salmon undergo a smoltification process where they transition from fresh to brackish water. Their body changes so that they can tolerate that extra salt intake and excrete it. And it's believed that these shallow water habitats provide an important refuge for them during this process. So I'm going to talk about this Fort Columbia and Megler Creek projects. They have similar landscape positions, but they're really different sites individually. Fort Columbia is a large impounded wetland with no real discernible channel. It reconnected almost 96 acres to the estuary, while Megler Creek has an amazing perennial cold water channel with really good quality spawning and rearing habitats. So it has a lot of potential to benefit salmon. Strangely enough, as tidal wetlands are really rare, both of these projects faced opposition from permitting agencies, and they both took a number of years to get completed. We ultimately decided to sample a fish community at these sites because they have the potential to benefit all salmon runs, since all salmon basically run through the estuary during their life cycle. It's really like a funnel. Everybody has to go through the estuary to get out to the ocean and back. As BPA is our largest funder, they're largely concerned with upriver stocks that have been more impacted by the dam. So we want to know how these lower river estuary projects benefit different salmon runs, specifically upriver runs. Metrics we selected were fish community sampling. So we sample with a seine and trapnet live box. We've also taken genetic samples. We have pit tag array currently at Megler. We had one at Fort Columbia for a couple of years in the past. And we're also going to be pit tagging fish at Megler with that array. So these represent some of our more intensively monitored sites. We've also collected macroinvertebrate samples, conducted channel cross sections, which is a series of elevation measurements at regular intervals from bank top to bank top. So we can see how the channels are changing post-restoration. We look at water surface elevation, water temperature, DO, conductivity, and salinity. So we haven't talked really about our monitoring designs. Ideally, we would want a before or after control impact design. This is a picture of Fort Columbia pre-project. So that tiny culvert was the connection from the estuary and Columbia River to the 96-acre wetland. For the most part, it's blocked by sediment and beaver activity. So this culvert obviously didn't accommodate fish passage, and the wetland behind it didn't have any discernible channels. It's still largely a complex scrub wetland with a lot of microtopographic diversity, no real channel. So because of that, we didn't do pre-project fishing inside. It just wasn't possible. And we didn't fish, that's what we were really interested in, because the outside habitat isn't going to change a whole lot after our restoration. So this is post-project, much nicer culvert. That's us doing some fish sampling. So we really want to compare who's hanging out in the estuary and who's coming inside to use our projects. This is Megler Creek, the one just upriver from Fort Columbia. Let's see. So Megler, it does have a perennial channel, so we were able to fish this in a before-after sample study. Not tidal inside, so slightly different methods pre and post. So when we're drafting our study plan, one of the things we think about is the methods. We can have the same metric, sampling fish community at a project pre and post like Megler and Fort Columbia, but have really different methods. So to sample inside Fort Columbia and Megler Creek, we used a trap net. Narayan showed you that. It has wings, and we set it up at high tide. And as the tide goes out, the idea is that all the fish that are in there are going to try to exit and end up in our live box so we can see who's hanging out in there. Outside, we use a seine, and that sort of acts as our reference for who's inside. So one of the things that we always try to think about are how we can compare the data with these different methods. Trap netting and seining can only have certain things compared. With seining, you can calculate fish density because you know the size of the net and the area that you're sampling. With a trap net, it's not that easy because technically you're sampling the entire stream. So we use catch per unit effort, which talks about, or which is basically the time fished and the amount of fish you catch. So we can look at presence absence and compare fish species inside and out, but we are limited with different methods, even under the same metric, for the data we can compare. Ooh, in planning our monitoring, we wanted our data from Fort Columbia to be comparable to Megler. The data we collect at Fort Columbia kind of informs how we expect Megler to benefit fish. What we see pre and post project at Fort Columbia is what we kind of expect to see at Megler. I didn't include a slide of it, but what we found at Fort Columbia post project is that there were a lot of coho coming inside and butting up kind of in that exchange of freshwater and brackish water, because the 96-acre wetland, well, it didn't have any channels. It's an intensely impounded wetland, so it's always kind of draining. And coho seem to love that habitat. Chinook primarily stayed outside in the estuary, as did chum. We sampled 2 years post-project, and the results were pretty consistent. We found similar things at Megler. Here's a shot of the outside. Megler was passable 60% of the time, roughly. So there was some passage into Megler, but the culvert is perched, so it had to be pretty high tide for fish to get in there. Pre-project, we found that there were Chinook and chum and a couple coho outside in that larger kind of little alcove, and inside it was primarily coho and trout fry. And they were probably resident cutthroat, the trout fry we were seeing. So,
Hey, April.
Yeah.
You mentioned there was some opposition to this project. Was that related to the existing passability affecting the cost-benefit analysis?
Ooh, yeah, I skipped over that. So it was slightly different. The opposition to Fort Columbia came from personnel in the Army Corps. They were intensely opposed to changing a freshwater wetland to a tidal one.
Oh, that's right.
Yeah, so that shut down the project for a little bit.
Changing it, yeah, but it was originally brackish, wasn't it?
Right.
Yes, and that's one of the things that helped us get this project going. So not only were we able to demonstrate with the Megler Creek pre-project data that there were Chinook outside and could potentially use that off-channel habitat, but then we look back at historic conditions. And that's largely what got these projects through, is that they were historically tidal wetlands. Megler is really unusual because a lot of the sites are pretty degraded. They're non-native species. You see warm water fish in there. But Megler was an exception. It was a real high quality forested wetland with almost all native species. So when we did a site visit with the Department of Ecology, who regulates wetlands in Washington and issues all those permits, quite a few people with DOE were really opposed to it because they just couldn't believe that we were going to drive excavators through this incredible forested wetland.
Oh, I see.
Yeah. Everybody's focused on their own piece. Yeah.
And it's understandable. It is kind of a shock because you go to sites and they're pretty nasty looking, and then you go to Megler and it's just this amazing habitat. So what got that through was demonstrating that it was historically tidal. And it took quite a bit of convincing to get DOE to sign off on it.
Excellent. And how far does the tide reach up into Megler now? Do we know yet?
A little over 300 feet.
Okay.
And before, I think it was maybe 30,
Yeah.
if that, maybe 10. It was that pool in front of the culvert. This is kind of the extent of the tidal reach.
Okay.
So, yeah, and then now you can see it goes up quite a bit.
Yeah,
So,
that's great.
so let's see. Where are we at here? All right, so this is the pre-project data we collected at Megler. This data was collected the same years that we sampled Fort Columbia, 2010 and 11. We would fish the inside on one day and then go out the next day and seine outside. when we fish inside and out, when we're trying to do comparisons, whether it's in and outside of the culvert or at a restoration and reference site, we try to sample really close together within that same week, preferably, you know, within the same series of days, so that we can try to capture the same fish communities. Fish community sampling is really hit or miss. We generally sample once a month. So it's a somewhat accurate description of what's there, but real limited, because we could have a pulse of chum that are migrating into the estuary one week and then not see them the next. So good data, but again, it's kind of hit and miss. So Megler pre-project, as we kind of talked about, the tidal influence extended, you know, less than 30 feet of the culvert. Fish data demonstrated this by the different species we saw inside and out. Only Chinook we caught inside, and because it wasn't tidal, when we set up our trap net and live box, we could leave it there all day and not really get any fish. They don't have to move, the tide's not going out, and we found that our nets do discourage them. So we started leaving it overnight. And the only Chinook we caught was a hatchery one that got into our net, and then was just having a feast on trout fry in our live box overnight. So that helped us kind of fine tune our equipment designs, and just let us know the impacts that hatchery fish can have on native fish as well. As you can see from the graphs, you know, we saw Chinook primarily outside. It was really different. It was basically Chinook versus coho. But you can also see the variability between the years too. You know, sampling just a year or two is really a small look at what actually is going on, because you get environmental variables. At one of our project sites, the first year post-restoration, we had record summer temperatures. So the water temperature data made it look like our project failed because it was colder pre-project. So one of the big things with monitoring is the duration at which you can do it. You really want at least 5 years of data to account for environmental variability between the years and seasons. We've just started post-project fish sampling at Megler. We're only sampling inside due to permit limitations. But it's going to allow us to compare fish presence between the two sites, Fort Columbia and Megler post-project. As I think we mentioned, the research at Megler includes a permanent pit tag antenna array, and we're actively tagging coho and Chinook to study their migration timing, how they use the site, and hopefully we'll get some adult returns. I don't know if our sample size is big enough to really calculate survival rates, but it'll give us an idea of not just the juvenile salmon that are in the site, but if adults are returning to spawn in there as well. All this data gets uploaded to PTAGUS, which is an online database for researchers in the Columbia River Basin. So a lot of hatchery fish are pit tagged. So we could get an upriver hatchery fish that was tagged prior to release. They're entered into the database, and if he's detected at our array or any other antenna array, that data is uploaded so researchers can share this detailed migration timing and information, habitat use data, you know, between organizations and across sites. So it's really informative, not just to us, but to everybody, and it's a way to cooperatively collect data that kind of benefits everyone looking to improve salmon habitat survival. So, and as Narayan talked about, a number of our sites, the majority of our sites are BPA funded, so we generally just do the AIMER level 3 metrics. This is an example of a site on the Clatskanie River. It's a ways upstream. It's a tributary to the Columbia. Historically, big forested wetland on part of it, and then a former cow pasture on the other side. This one was a massive levee breach. It took over 7 years to see through completion. It was met with intense landowner resistance, threats of lawsuits, but also had exceptional landowner support. There was a land exchange and a cross levee built. So, you know, a couple different private landowners came together to make this happen. I think it reconnected over 30 acres of former tidal wetland. And that's kind of one of the underlying themes, is trying to encourage habitats back to what they were historically. This would have been an ideal site to monitor successional changes in plant community between a forested wetland and a former pasture. It's one of the sites where it's frustrating to be limited to really basic metrics. But still, we're able to collect some good data there. So what we're going to talk about, moving on, are some of the sites where we have collected more intensive data. But this we wanted to show you to give an idea of kind of our basic monitoring sites. We collect water surface elevation. We had our data loggers in the main stem stolen, vandalized. Some I think got washed away. So, and then post-project, some of our monitoring metrics were damaged by trees washing in. So there's always unforeseen things that can happen to your data collection. We have almost no pre-project data, unfortunately, because of vandalism to our equipment. But we do photo points, sediment accretion, and water surface elevation and temperature at this, as we do with most of our other BPA sites. So here's one where we've been collecting data for quite a long time. Narayan will talk about this site.
Yeah, just FYI, guys, that we have about 5 minutes, and then we should open up to questions.
Okay.
Okay. This slide just pictures Colewort Creek at Lewis and Clark National Historical Park. This is pre-restoration with a small culvert, and then a bridge was put in. And due to proximity to Astoria, our office, we were able to implement a bunch of metrics. Colewort provided the opportunity to sample both the restoration and a close reference site, which we normally don't have the opportunity to do. We were also able to sample 1 year before restoration at Colewort, which allowed for a before-after control impact study. We also partnered with LSEP to conduct a 5-year study, which allowed us to employ more metrics than we normally do due to funding. In conjunction with fish community, we collected fallout trap samples, benthic cores, gut samples from juvenile salmon, macroinvertebrate sampling, coincided with the fishing events so that we could compare the prey site, what prey the site was producing to what prey salmon were actually selecting. Yeah.
Wait, hold on. Okay, so real quick, this is an example of one of the projects where we used some adaptive management. This was where the reconnection took place. This side, real low elevation, great plant community, a lot of inundation. This side, heavily compacted from fill material and also cattle and horses. So phase 2 of Colewort entailed going into here and cutting some channels and making this habitat more complex. So that's an area where, a project where our monitoring really helped to kind of fine tune the work that was done.
Site similarities such as landscape position allow us to compare certain factors such as species composition, prey selectivity, and availability. At the same time, differences in site conditions were apparent in the data, which gave us insight into how juvenile salmon use slightly different off-channel habitat that is in the same landscape position and river reach. This slide shows just 1 year of data, but the trend of seeing more coho at Colewort and more Chinook at the reference site was consistent through all years sampled. So despite these sites being very close to each other, they they have different abundances of different salmon species. So this could be used as a model to concentrate projects and have different outcomes to cater to different life history types and different species. I'll just run through this slide real quick. This is the water quality. These are some of the metrics that could be collected. We mostly focus on water surface elevation and temperature, but at some of those more studied projects will employ dissolved oxygen as well. This is deep widgeon on Savi Island. Sorry. Deep widgeon had a impaired water control structure, and behind it was a big wetland and a channel. Before restoration, it's easy to see with the inside being blue, the red being outside, that the inside tidal signature was very muted compared to the reference outside. Once that water control structure was taken out, this bottom graph shows that the tidal signal was virtually the same afterward. And what does that mean to salmon? That means more habitat opportunity from the reference into the actual wetland site. Here we have water surface elevation and temperature. These slides show their relationship. So Dibley Point was an alcove directly off the Columbia River near Longview. And here we can see it was impounded by a undersized perched culvert. This blue line is inside the alcove. There's no tidal activity at all versus the outside where you can clearly see the tide. What does that mean to temperature? Well, research states that if water is impounded and flow is restricted, temperature goes up. And that we can see here where the blue line is inside, it's always higher than the red. Once restoration happened and larger culverts were put in, water surface elevation, boom, it's pretty much the same inside and out. This is funny because temperature didn't go down necessarily on the inside, which April mentioned. You know, the environmental factors are a big issue, so you have to monitor more than 1 year and take an average of multiple years.
That year was the one that was unusually hot.
Dissolved oxygen. We normally don't employ this, but we will sometimes. The graphs on the slide illustrate the relationship between increasing water temperature and decreasing DO as seasonal time progresses. At both sites, it's apparent that although temperature exceeds the thermal stress threshold of 19 degrees Celsius, the DO remains above the 5 milligram per liter critical threshold. That's all I'll say about that for now.
Here's an example, kind of the timeline of monitoring. If we look at this site 1 year post-restoration, we went from a vegetated area to a complete mudflat, which is a pretty big red flag for permitting agencies, Department of State Lands, and DOE. They both don't want us to take vegetated wetlands, even if they're non-native plants, and modify them so that they become an unvegetated mudflat. So 2 years post-restoration, you can see it's doing incredible. So really, we really have to look at our timelines when we're monitoring and make sure that we're looking at the sites long enough to see what changes are really going to take place over time. Macroinvertebrate abundance, we talked a little bit about that and how the native plant community can provide different prey availability than like the strict monoculture of reed canary grass, which we see at a lot of our sites. The macroinvertebrates, the terrestrial ones that we look at, they vary throughout the summer, but it was pretty consistent that the native marsh was more productive than the monoculture, which isn't a huge surprise.
So this is Ruby Lake on Savi Island. The left here is pre-project, the right is post. There was a water control structure somewhere up here that was impeding water hydrologic flow through here. So this is all reed canary grass, which is a hell of an invasive that we have to deal with. It creates huge stands of a monoculture plant community. Once that water control structure was taken out and some marsh elevation lowering was done, some scrape down, you can see that the water is tidal again with the river, the main stem. This allows the rhizomes and the reed canary grass to be kind of drowned out, and natives will take over like Wapato. And we've done vegetation surveys in here, and there's virtually no reed canary grass within this flooded area. It's all native. Okay, here's our last slide. Channel cross sections. Since elevation, hydrology, and substrate are key factors in plant community development, sediment accretion and channel morphology sampling allow us to monitor these factors over time. This information, along with site-specific characteristics, helps inform project design. So basically what we're looking at here, at Colewort Creek, this was pre-restoration, or I'm sorry, these are both after restoration. This was immediately after restoration. We can see that once hydrology was restored, 1 year after that, it carved out, and this was a created channel. It carved out the created channel. Whereas over here at Fort Columbia, the channel stayed at the same elevation because research states that historic channels will always revert back to their historical elevations. So at Fort Columbia, the banks eroded instead of the channel getting deeper. In conclusion, so we focused on fish community, prey, water surface elevation, vegetation, and channel cross sections. Fish community is a direct measure of how the species responds to restoration. Habitat features such as water temperature, vegetation, prey availability, and habitat opportunity provide information on the site productivity. Many of the other metrics that are valuable and information, such as fallout traps and dissolved oxygen, are just too labor intensive or costly. So while monitoring metrics can help prioritize projects, selecting metrics is in itself a matter of prioritization. Here's our references. All right, questions?
That was excellent. Really, really great. I mean, from my end, it's so satisfying to see some of these projects get implemented. And then also, it's doubly satisfying to see some good data come out of them, so thank you. All right, folks, do you have questions?
I just have a quick one. So a couple of slides ago, you showed a project that was kind of a mud flat 1 year after the restoration and then revegetated a year after that. How often do regulatory agencies come out and kind of inspect the progress and make sure that it is restored to their satisfaction?
It depends. It depends on the agency and the type of project. They want us to monitor for 5 years post-restoration, but a lot of times we don't have the funding to do that. And these BPA-sponsored projects, they don't allow us. They don't fund us to look at vegetation. So the regulatory agencies kind of have to balance what they want and their demands with what we can actually do. So if they set a standard that we have to monitor vegetation for 5 years, some of these projects just wouldn't happen. So what they want and what they get are kind of two different things. I think generally they want to see data for 5 years.
Okay. Excellent. Thank you.
I have a question for you. Did you, what percentage of your skills that you demonstrated today did you learn on the job?
Really, almost all of them.
That's what I thought. obsolescence of higher education.
Yeah, there's I've gotten a lot more out of this work experience than school, but that's, you know, everyone's education experience is different, and I did my schooling online, so that kind of limited how beneficial it was to me. But yeah, our job is so site specific, and the things we focus on have changed over the years. So CREST is great because it pays for a lot of training with so just doing the work and then learning to do things on our own, and also training on the job has helped.
I second that. My background was fish, basically, so I could handle all the fishing, but all the botany work and macroinvertebrate work, surveying, I had to pretty much learn that on the fly while at CREST.
Thanks for your honest answers on that.
Yeah.
Stay
All right,
in school, though. Stay in school.
School.
These folks are nearly done.
Well, good. Congratulations.
Time for one more, if anyone's got a quick one. No?
I have a question about database. Somebody else can ask. So I've worked a lot in the last 4 years on large database management, database science, and so on, both through the Northwest Climate Science Center, which attempts to be a repository for these kinds of data sets, and through Northwest Knowledge Network, which is a university network. You folks mentioned big data and the attempt to get data in central repositories. Have you had any experience with specifically the Climate Science Center, the USGS DOA Climate Science Center on that? I noticed you have experience with other agencies.
Interesting you asked that. I just went to a conference down in Newport about water quality monitoring, and I did meet with someone from the USGS because that was one of the big themes, was how to compile data with a multitude of agencies. So we're looking into getting our data out there and just data sharing in general, because that would help us too for our restoration projects. But other than talking to someone that worked there, I don't remember their name, that's all the experience we have.
I'll get hooked up to you through Micah, and I'll send you a couple of pieces of information.
We're happy to connect with you.
Great,
Yes.
thank you.
So in terms
April,
of,
one sec. One last question here.
So if you're trying to develop sort of like a big database where everyone shares everything they've found on their projects, is there also some sort of like protocol being developed for like formatting that data so that it's all comparable, so it's useful between multiple agencies and different projects?
Yeah, at least with what we deal with is Encore, put up by the Army Corps of Engineers and LSEP. They're data exchange templates, which are basically Excel spreadsheets that they just lay it all out for you. And you have to enter in all the data in these data exchange templates and then implement a QA/QC, send them in. And then I've gotten a call from PNNL before asking me, how did you get this number, or why is this like this? So someone's looking at it, making sure that we are QA/QCing, but there is structure involved with data exchange templates.
Thank you.
Okay. April, did you have any last words for us?
yeah, so real quick, one of the things I've noticed over the years, CREST is a little different because we don't publish research, but I found that one of the biggest roadblocks to data sharing is, you know, people wanting to publish the results of their data and not willing to share that data until they've gotten their paper out with their name on it. So, especially with universities and, you know, people who do more research. So that's kind of an obstacle too.
Gotcha. Good point. Okay. Thank you so much.
Thank you.
Thank you.
Thanks, guys.
That was tremendously helpful. And we look forward to talking to more CREST folk next week. But we appreciate your time and expertise. Thanks again. Hey, one personal note for you both. I'd like to connect sometime in the near future about your drone program.
Okay.
I'm putting together a research program looking at drones for use in wetland restoration effectiveness monitoring. So it'd probably be a good idea to compare notes and see what you all have in mind as well.
That sounds good. I must warn you though, our program is in its infancy.
Mine too.
All right, then we can collaborate.
That's totally fine. No, I got licensed this last year and we've been using it sporadically for research, but coming up we'll be specifically using it for some wetland restoration work. So it'd be great to pick your brain.
Yeah,
I'll send an email. Maybe we can set up a short phone call.
What?
Can I turn the
sounds good.
I
Okay.
prefer that you
Enjoy hearing from you both. Thanks again.
It's uploadable.
Bye, Micah.
Thanks, nice to meet you. Bye.
Just,
All you do is click on your file name.
just because I only have a hard copy of it, and I don't have a scanner.
Oh, you don't have a scan?
No.
You can bring it in.
Okay,
Just make sure you hand it
it'll
to
be
us.
super done.
Yeah, make sure you hand it to us so it doesn't get lost.
Okay.
Because we've been operating pretty much paper.
Walkie talk?
Yeah.
Yeah,
Okay, cool, thank you.
Yep, no problem.